Hello everybody, this is Dr. Christopher White, and in this video we are going to be looking at the relative dating assignment. Alright, let's get going. So what have we got? Well, on page 1, as you can see here, we have a general description about relative dating. Please read it. And we have the 7 principles of relative dating listed here. So once again, we have superposition, original horizontality, lateral continuity, cross-cutting relationships, baked zones, inclusions, and faunal succession. So we're not going to be dealing with the principle of faunal succession today, and we're not going to be dealing with the principle of lateral continuity either. The principle of lateral continuity, it would seem, is missing an O. My mistake. So okay, so the question is then, what are we doing? Well, the answer is starting at part 1. Alright, so here's part 1. What does it ask you? What does it ask us to do? So on the next page, alright, you can see we have this diagram. Now this diagram is of the Grand Canyon. So what part A wants us to do is it wants us to use the principle of superposition to essentially produce a chronological order for the layers of rock that you see in this diagram. 1 being the oldest layer, and I'm not sure how many layers there are. Let's just say for argument's sake 12, 12 being the youngest. So you would have a list going from the oldest layer, number 1, to the youngest layer, 12. Okay, so remember, the bigger the number, the younger the layer. So that's part A. Part B then asks us which, oh, I'm having a really bad spelling day, aren't I? Nope, let's correct that right now, because we are not talking Old English. Which 3 layers in the Grand Canyon sequence do not conform to the principle of original horizontality? Alright, so if you don't remember what the principle of original horizontality is, take a second, go back to the lecture and find out. Okay, I'm not going to tell you. You should know. Okay, question C, which layer is the oldest? Question D, which layer is the youngest? So you're going to be using the principle of superposition for both of those. Okay, so part 1 is super duper easy. What about part 2? Could it possibly get easier? Maybe it can. Okay, so part 2 is going to deal with cross-cutting relationships. So the first part, part A, deals with this block diagram here. So it's simply going to ask us to put the rocks in a chronological sequence. 1 being the oldest rock, 4 being the youngest rock. So this is relatively straightforward. It's a mixture of the principle of superposition and the principle of cross-cutting relationships. One thing I would like you just to take a second to note, and it's something that some people do seem to miss, is that the dike here is cut off. Okay, it's been truncated. So the dike in theory should have continued up and up and up and up, but the dike, any dike rocks above this level have been eroded away, they're gone. Okay, so we have an unconformity right here. Alright, so please just bear that in mind. Okay, so once we've done part A, we're going to move on to part B. So using the diagram below, which is older, the fault or the dark layer of rock? Alright, well let's see. There's the fault. And here is a dark layer of rock. We've got one part of it there, and the other part of it comes round like so. Okay, you can probably work that one out relatively easily. Question C, using the diagram below, right, this one right here, which is older, the fault or the dike? Well, the fault is here, the dike is here, so we're using the principle of cross-cutting relationships on those two. Okay, so I think we're going to agree, part 2 is quite easy. Alright, part 3, well, I'm afraid it's going to get a little bit more complicated here. Not too much, but a little. So what we're going to do is we're going to look at the picture on the next page, which shows a granite intruding a sequence of sedimentary rocks. Okay, so here we go. So what I'm going to do is I'm actually going to zoom in on this diagram a bit, just so we can see what's going on in a little bit greater detail. Okay, so what have we got? Well, you can see here's our granite, labelled granite, nice and easy. And we can see that this granite is essentially cross-cutting all of these sequences of sedimentary rock, isn't it? It's pushing its way through, and essentially it's cross-cutting them. Now we can see that we have inclusions of all of the layers of rock in the granite. So we have this breccia down here, you can see a piece of it there. We have this, well, it's probably a grey mudstone here. We have this light grey mudstone here. We have this sandstone layer here. We have this limestone layer here. And we have this conglomerate here, here, and here. So we can also see that not only is the granite cross-cutting those layers, but it also contains inclusions of them. So if you're uncertain about what that means, go back to the lecture, please. Now, as we continue up, we will notice that the top of the granite has been truncated, just like the dike in that earlier image. So you can see it's been eroded away. So we've lost the top of the granite here, it's gone. Now, obviously, this means this, therefore, must be a unconformity. Now, what do we see, though? We see pieces of the granite in this sandstone layer. Okay, so bear that in mind. It's going to help you date the order of events. Okay, so what are we trying to do? Well, the first thing is we're going to look at these 4 statements here, and we're going to try and put them in the correct chronological order. 1 being the oldest, 4 being the youngest. So what are the statements? Well, A says intrusion of the granite and inclusion of surrounding sedimentary rocks into the magma. B, deposition of flat-lying sediments followed by tilting of those sediments. C, deposition of flat-lying sedimentary rocks and inclusion of granite pebbles in the overlying sandstone. D, erosion of the granite and tilted sedimentary rocks. Okay, so you just have to take a second and you have to put these in the right sequence. Okay, if you're uncertain, work it through in your head. Okay, think about how this has to go. Remember, all sedimentary rocks are deposited as horizontal layers. Therefore, if they're tilted, that must come after they are deposited as horizontal layers. Okay, so just remember that point. Okay, so what's next? Well, we come on to part B. So using a coloured pencil, we are going to draw a line along the margin of the granite to show where you would expect to see a baked zone. Okay, think carefully about this one. All right, so we know that the granite intruded the sequence of tilted rocks. Okay, so where would we expect to see the baked zone? We'd expect to see it essentially over to you guys. Okay. Now, once again, though, take a second and think. Okay. Yes, you would expect to see the baked zone where you would expect to see it. Okay. However, it's not continuous. All right. So just think why it's not continuous. And that means the line isn't going to continue all the way. There's going to be some of it that might not be baked. And, you know, the principle of inclusions would tell you why. All right, so please bear that in mind. So what about C? So for part C, name the 2 types of unconformity present in the diagram. Assign each type a colour and mark them on the diagram. So name the 2 types of unconformity here. Give each type of unconformity a colour, and then mark their position on the diagram. Okay, remember the unconformity types are angular unconformity, disconformity, nonconformity, and paraconformity. Okay, so that was part 3. It's a little bit more complicated, but as long as you concentrate on what's going on and you sit down and actually think about it for a few minutes, you'll be absolutely fine. Okay, and finally on to the last part, part F, which is block diagrams. Now, these block diagrams are extremely common in geology. Okay, we love to use these things for tests. Hint, hint. So you should make sure that you sit down, try and understand what's going on, because there's a very good chance they may appear at some point. Final exam, maybe. Okay. So what have we got? Well, we can see if we come onto this page, I'm actually going to zoom out because I'm very, very tight. As you can see, when we zoom in, we can see we have 1 block diagram here and 1 block diagram here. And underneath it, we have a line, a dashed line. And essentially each one of these is where you're going to write the letter for a layer of rock, and you're going to put the rocks into a chronological order. Okay, so as we can see when we look at this diagram here, we're going to be using things like the principle of superposition, the principle of original horizontality, and the principle of cross-cutting relationships. So, as you can see, all you've got to do is just put the layers of rock in the correct sequence. Remember, intrusions and faults must be younger than the rocks which they cross-cut. Please excuse me, it's been a long day. So just remember that, okay? Also remember, tilted layers of rock were originally horizontal and then tilted, okay? So don't forget that as well. So this one at the bottom is actually the diagram you should start with because it's a little bit easier. Now up here we have the slightly more complicated diagram, okay? Now there's a few things I'm just going to make sure that you notice. First of all, K, the granite here, has inclusions of B and A in it, okay? That's going to help you to work something out. You should also know that K is truncated right here, isn't it, by this erosional surface, marked out by the wiggly kind of emboldened line. So what else is going on? Well, obviously we have M, which is clearly a fault. Now the thing you need to notice about M is it cuts C, D, and E. It does not cut F, G, and H. So there's a lot of people that simply say, now remember, we're going to use the principle of superposition in this instance. They say, right, I'll do C, D, E, F, G, H, then the fault comes in. Or you could argue it's C, D, E, fault, F, G, H. Okay, it's personal preference. It's actually impossible to work out what the correct answer is because the fault would of course continue all the way up here and any rock above this unconformity has been lost, so we will never know the answer. Okay, so it's a matter of personal opinion as to which option you prefer. I should also point out that L cuts everything. Okay, so those are the last two diagrams. Oh, I should also point out there's a little question here. Please don't miss it. A lot of people do. So what type of unconformity is between layers B and C? So there's layer B, there's layer C. What type of unconformity is it? Okay, that's it for the relative dating lab. It is a very simple, very relaxing kind of lab. So take a few minutes. You should be done with it in about 20 minutes tops. Okay, everyone, have a good day. Bye.